Thanks again for checking out this video in my tutorial series Solidity Beginner to Intermediate. So in this video we're going to discuss overflow and safe math. Before we get into that topic though, there's one thing I think I overlooked in the previous video, and that is explaining what this interface is on the screen. So we're using interface called Remix. It was developed by the Ethereum Foundation, so that's remix.ethereum.org. So this is basically an interface that allows you to develop smart contracts really quickly without having to deal with the infrastructure behind it, like setting everything up, making sure everything is configured. This is just a really quick way to build smart contracts, especially as beginners, but even professionals use this all the time. I use it all the time. Lots of developers use it all the time, but eventually you're going to want to move to a different environment where you have more fine-grained control. But this is definitely a very important tool to understand. All right, so let me just go over the basic features of it, and if you want more detailed examples, you can check YouTube. There are so many videos on it and other places, but let me just get you familiar with enough that we can actually develop smart contracts on this. So if you click on this tab, you're gonna see this is the File Explorer section. This is where you store all your different files, different scripts that you build, and to be clear, this is not permanent storage. This is just stored in your browser. So make sure you don't put anything here or save anything here that you're gonna want to keep for a long time. So this is all disposable stuff, so it's just in your browser storage. All right, another section here is you can search different files. In this section right here is a compiler, so you can select the different compiler versions you want to use. You have a button here you can click that and it just runs a compiler, checks your code. You also have the option of selecting auto compile, so you don't have to worry about clicking this button. So as you write code, it just automatically compiles it, and then you'll see this green check here, and this is just letting you know that your code compiles. If this turns red, you know that you have a problem in your code. Something's wrong with the syntax. All right. And right here is the deploy and run transaction section. So they actually give you a nice little interface here. So here you can choose a provider. You have multiple providers. The ones that start with Remix VM, these are virtual machines provided by Remix. Injected provider, this is your actual MetaMask wallet. It's actually showing the account that's on that wallet. With these virtual machine ones, you get a bunch of accounts with test ether attached. Yeah, and there's a few others. You have this section for gas limit. You can actually edit the amount of gas you want to use on each transaction. And we'll talk about gas in another video. And this is the value. If you want to make a smart contract call and send it some ether, this is where you'd actually add that. These are the different units. Way is the smallest unit of ether. Ether is the largest. And once your contracts are compiled, you're gonna see a list of contracts right here in this section. All right, so that's the basics of Remix. So now that that's out of the way, so let's talk about overflow. So in Solidity, there is, so for each storage unit, right, the smallest storage unit in Solidity is 8 bits, right? If you go over, actually, let me not start there. Let me actually just write some code and show this to you before explaining it. So contract called safe math. Let's do uint 8 All right. So uint8 public variable called number 255. So this is the largest number that can be stored in this data type. If it goes over, if you were to add to this number, it will do what we call an overflow. Basically, number would reset to 0 because there is no more space. So you're just basically resetting the number. And to be clear, you can write that this way also, public so that would be the same as 2 to the power 8 minus 1, like I explained in the previous videos. All right, so this is the most you can have. So let me compile that and show you. All right, so see the public variable number, if I click that, it's 255. So it's the same as this. All right, so I just put that, I just wrote it like that just to make it as clear as possible. All right, so if we were to increment that number now, if we were to increment that number, it would actually, wait, actually, let me change this compiler version, and I'll tell you why in a second. It's a good one, 511. I'll tell you why in a second. All right, so if I was to increment this, this would turn into 0. So let me show you what that actually looks like. So deploy, wait, let me get rid of that. All right, deploy. All right, so if I click number, you see it says 255, right? Good, because that's what number is, 255. If I was to click increment now, so add 1 to 255, and I click number again, look, 0. We had an overflow. All right, so what happened is, to solve this problem, for a long time there was this library that was provided by OpenZeppelin called SafeMath. So SafeMath would throw an error if you actually did an overflow calculation, right? So notice how with this version of Solidity, there was no error thrown. Everything looked normal. There was no problem. You incremented, it overflowed, and there was nothing to stop you, no checks. So this library took care of that. So this library is no longer needed. As you can see right here, SafeMath is generally not needed, starting with Solidity 0.8, since the compiler now has built-in overflow check-in. So the compiler has built-in overflow check-in, right? So if I was to go back to 8, is there 811? Yeah, there is. So if I was to go back to 8 now, I would not have that same effect. Let's deploy. All right, so number is 255, increment, nothing happened. See, it didn't allow the overflow to happen. All right, so there is a use case for allowing an overflow, not necessarily to happen, but not to, yeah, well, I would say to happen. So basically, doing that will save gas. So if I wrap it in this unchecked, if I were to wrap it in that, it will allow that overflow to happen, right? Number 255, increment number 0. Even though we are in Solidity version 8. The reason for that is that this is gas efficient, right? You're gonna use a considerable less amount of gas once you wrap it in unchecked, right? And so you're only going to want to use this feature once you're absolutely sure that the number that you're using has no chance of overflowing, right? So that's basically what I want you to understand. And this right here is probably the most complex mathematical part of Solidity, is just understanding this overflow underflow concept, right? So this also happens in the opposite direction, and it happens for uint and int. It doesn't make a difference. Once you've used up the amount of memory allocated for that data type, it's gonna either overflow or underflow. All right, and so yeah, so you have this unchecked feature, and that's only found in Solidity 8 and up, and so that allows you to have more gas efficient transactions, but you just have to be very careful how you use it. You have to just understand where and why you're using it, and you for most cases you're gonna want to only use it once you're sure that you're not gonna overflow. Now, I'm sure there's some creative ways to actually make a number overflow, and that's how you design the application. I mean, of course, that's also allowed, but understanding how this works is very important. Okay, so I hope that was clear enough. I think you should understand what I'm talking about. If anything's not clear, just leave me a comment. I'll try to explain it a little bit better. But yeah, so that's it for this video. Thanks for checking it out. Like, comment, share, subscribe, turn on post notifications, and I'll see you in the next.